Hello and welcome to 5 Minutes RF Pro Tutorials. This is tutorial 4 on user-defined EM analysis using momentum and FEM. Before we start, remember 1, 2, 3, subscribe to the channel, enable the notifications, and like and share the video with your friends and colleagues. All right, so let's go ahead and understand this wonderful capability in the RF Pro to perform a selective user-defined EM analysis. To demo this feature, I do have a multi-layer laminate design here as a case study where you can see the stack up. It's a 6-layer stack up with a cover plate at the bottom. So this is the stack up we are going to use for our simulation. Now, if you have watched my previous videos, you already know how to run RF Pro by clicking on this icon or by going to Tools RF Pro and create a new setup. Now, once you load the RF Pro, the entire design database gets loaded. In the previous two videos, I spoke about how to run a full EM analysis, which is to simulate the complete layout. But in many cases, if you're dealing with a complex geometry, you may or may not want entire simulation to happen. But before that, you would like to verify the key critical interconnects and how well they are performing with respect to the frequency span you have in mind. So in this particular case, it might be possible that so let me first put the conductors to wireframe. And let's say you are only interested in analyzing this critical interconnect, or you can press Control key and select multiple interconnects. So once you click on that, you can see the appropriate nets are selected from the list. Now, once you select a specific net which you are interested in simulating, you can simply drag and drop it over to user defined. So in my case, let me create a new user defined extraction, and you can give it whatever name you want. But in this case, let me select this particular net. So you could either click on the GUI to select a net or click on this list. And you can simply drag and drop it under nets. Now you also need a ground. So you can also select and add a ground net to your part of your analysis. Now, once the net is here, the ground is here, the remaining thing you need is to create port. And all the pins, as we spoke about, which you have placed in layout, you can also see under this net. And these pins you can drag and drop under ports, and automatically 2 ports will be created for you for RF Pro simulation. Now, if I see this geometry from the y-axis side, you can see plus is on the top layer, the minus is on the cover plate because our stack up includes the cover plate. Now, in this kind of multi-layer design, it is also possible that you would like to have one of the internal layers of your multi-layer design to be used as a ground reference. In that case, you could simply right-click on reference pin, and here under layer, you can select, let's say M2, M3, M4, whatever layer you want. In my case, I have added M2 as one possible location for RF Pro to create a port. Now, once that is done, and you have these 2 pins which are having minus pins located at cover plate, and that's why you can see there's a warning here, and this warning is absolutely fine. If you want to keep minus at the cover plate, is absolutely fine. You can proceed with simulation. But sometime if I want to use M2 layer or M3 layer for my negative pin, I could simply right click and say create and use virtual pin on nearby ground net. Once you select this option, automatically RF Pro will create the virtual pin on the nearest ground layer or ground net. And you can see in this case is M2, and we also added M2 here. So RF Pro has the authority to create a negative pin. You could do that, and same will be used inside your port. Now, once that is done, you are almost there. Only option left is double click on the options, set your frequency span in which you would like to run simulation. Go to simulator, either select momentum or FEM. This option is common and you can use either of the simulator. And let's say in my case, I would like to invoke FEM. And then you can go to the setting. There are 2 things you need to do when you run user defined EM. Number 1, in the mesh generation, select generation 2, which is the latest generation mesher with a lot of enhancement and new capabilities. Second is to select mesh domain optimization to be switched on. And I will explain in a bit what does this option do. So by switching mesh domain optimization on, remember you are only simulating a portion of your design, right? So you're only selecting this specific net, but the ground is scattered all over the place. So there is no fun simulating such a big ground when you're only simulating a specific portion of your design. Once you switch on mesh domain optimization, then the simulator itself will restrict the ground to the most relevant portion. So it will limit the problem size, give you the best advantage of RAM and speed. And once you're done, you can go ahead and start running the simulation. I already have ran the simulation because it takes a couple of minutes, and exactly the same nets which I just showed you, I added here. There are a couple of ports which got created on, and the portion, the negative pins are kept on M2 layer. You can see it here. The pins are placed in M2 layer, and the simulation takes about 2 minutes on my laptop to run the analysis, and it takes around 2.8 GB for full 3D FEM. And once the simulation is complete, you can look at S parameter to look at either the Smith chart plot, which you can see here in terms of S11 or S22, or you can switch on an XY plot and look at S11 and S22 or S21, depending upon the graph of interest or the figure of merit of interest. It's also possible, if you want to find out how much is the inductance produced by this trace, you can switch from S parameter over to inductance, and now you can see the inductance which is produced by this trace. So all of these things are at your fingertips. You can get productive very, very quickly with using this nice capability. So I hope you like the content presented in this video, and this feature will be very useful for different kind of applications you have, whereby you don't need to simulate the entire design at once. You can focus on critical interconnects first, make sure they are giving you the desired output, and once you are happy, then you can go ahead and commit yourself to run a far more complex simulation, which is going to take a little bit of more time and more memory. So thanks a lot for watching this video. Stay tuned for upcoming interesting videos.